National Electrical Code Article 500 addresses hazardous classified locations. The purpose of Article 500 is to provide safety requirements for electrical installations in hazardous classified locations where flammable or combustible liquids, gases, or vapors are present. The scope of Article 500 covers the design, installation, and operation of electrical equipment and systems in hazardous locations to prevent the ignition of flammable or combustible atmospheres. Hazardous locations are classified into divisions based on the probability and extent of the presence of flammable or combustible materials. Division 1 locations are those where hazardous materials are present in sufficient quantities to produce a hazardous atmosphere under normal operating conditions. Division 2 locations are those where hazardous materials are present in sufficient quantities to produce a hazardous atmosphere only under abnormal operating conditions. The National Electrical Code defines 4 types of hazardous locations based on the characteristics of the flammable or combustible materials present. Class I locations contain flammable gases or vapors, for example, gasoline and propane. Class Roman II locations contain combustible dust, for example, wood flour and grain dust. Class Roman III locations contain easily ignitable fibers or flames, for example, textiles and fibers. It should be noted that there isn't a Class Roman IV location, so let's continue with the other classes. Locations containing combustible metals, for example, magnesium and titanium, are included. Electrical equipment installed in hazardous locations must be designed and constructed to prevent ignition of hazardous atmospheres. This includes the use of explosion-proof enclosures, the use of intrinsic safety barriers, the use of purge systems, and proper ventilation. Electrical installations in hazardous locations must be inspected and maintained in accordance with the National Electrical Code. This includes proper grounding, protection for corrosion and heat, adequate ventilation, and proper bonding and sealing. Electrical systems in hazardous locations must be periodically inspected and maintained to ensure they are operating properly and safely. This includes visual inspections, electrical testing, and regular cleaning and maintenance. Compliance with Code 500 is essential to ensure the safety of persons and property in hazardous locations. Failure to comply can result in fires, explosions, and other dangerous incidents. The National Electrical Code, or NEC, is a comprehensive set of standards that outline safe electrical practices. Article 500 within the NEC specifically addresses electrical installations in locations where fire or explosion hazards may exist due to flammable gases, vapors, dust, or fibers. These are known as hazardous or classified locations. The NEC classifies hazardous locations into different classes, divisions, and groups, each with specific requirements for electrical equipment and wiring. This classification system helps to ensure that electrical equipment used in these areas does not become a source of ignition. Class I locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Examples include petroleum refineries, gasoline storage areas, and spray finishing areas where volatile flammable solvents are used. Class Roman II locations are those where combustible dust is, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Examples include grain elevators, flour mills, coal preparation plants, and areas where metal dusts are produced or handled. Class Roman III locations are those where easily ignitable fibers or materials producing combustible flames are handled, manufactured, or used. Examples include textile mills, woodworking plants, and facilities that process cotton or other fibrous materials. Within each class, there are 2 divisions that further define the likelihood of a hazardous condition existing. Division 1 locations are those where the hazardous material is present under normal operating conditions, or where it may be present frequently because of maintenance, repairs, or leakage. Division 2 locations are those where the hazardous material is present only under abnormal conditions, such as a container rupture or system breakdown. In addition to classes and divisions, hazardous locations are also grouped according to the specific flammable or combustible substance involved. These groups are based on the ignition temperature, explosion pressure, and other characteristics of the substance. Group A includes atmospheres containing acetylene. Group B includes atmospheres containing hydrogen or gases or vapors of equivalent hazard such as manufactured gas. Group C includes atmospheres containing ethyl ether, ethylene, or cyclopropane. Group D includes atmospheres containing gasoline, hexane, naphtha, benzene, butane, propane, alcohol, acetone, benzyl, lacquer solvent vapors, or natural gas. Group E includes atmospheres containing combustible metal dusts, including aluminum, magnesium, and their alloys. Group F includes atmospheres containing carbon black, coal dust, or coke dust. Group G includes atmospheres containing flour, starch, or grain dust. The NEC specifies detailed requirements for electrical equipment installed in hazardous locations. This equipment must be designed and tested to prevent ignition of the surrounding atmosphere. Explosion-proof equipment is designed to contain an internal explosion without allowing it to escape and ignite the surrounding atmosphere. Intrinsically safe equipment is designed to operate with such low energy that it cannot produce a spark or thermal effect sufficient to ignite the hazardous atmosphere. Other methods of protection include purging and pressurization, which involve maintaining a positive pressure of clean air or inert gas within an enclosure to prevent the entry of hazardous substances. The NEC also specifies requirements for wiring methods in hazardous locations. These requirements are designed to prevent sparks or arcs that could ignite the surrounding atmosphere. Conduit systems must be sealed to prevent the passage of gases, vapors, or dusts. Fittings and boxes must be explosion-proof or dust ignition-proof, depending on the class and division of the location. Wiring must be properly grounded and bonded to prevent the accumulation of static electricity. All electrical equipment and wiring in hazardous locations must be properly installed and maintained. Regular inspections and testing are essential to ensure that the equipment continues to function safely. Any damage or deterioration must be promptly repaired. Personnel working in hazardous locations must be properly trained in the safe use of electrical equipment and the hazards associated with the specific substances present. Compliance with the NEC requirements for hazardous locations is essential to protect people and property from the dangers of fire and explosion. Failure to comply can result in serious injuries, fatalities, and significant property damage. It is important to consult with qualified electrical professionals and to follow all applicable codes and standards when designing, installing, and maintaining electrical systems in hazardous locations. The NEC provides detailed guidance on the selection, installation, and maintenance of electrical equipment in hazardous locations. It is essential to carefully review and understand the specific requirements for each class, division, and group of hazardous location. By following these requirements, it is possible to ensure that electrical systems operate safely and reliably in even the most hazardous environments. The NEC is constantly updated to reflect changes in technology and best practices. It is important to stay current with the latest edition of the NEC and to consult with qualified electrical professionals to ensure that your electrical systems comply with all applicable requirements. The NEC is not a substitute for sound engineering judgment. It is important to carefully consider all aspects of the installation and to select equipment and wiring methods that are appropriate for the specific application. The NEC is a valuable resource for anyone involved in the design, installation, or maintenance of electrical systems in hazardous locations. By following the requirements of the NEC, it is possible to create a safe and reliable electrical system that protects people and property from the dangers of fire and explosion. Compliance with the NEC is not only a legal requirement, it is also a moral obligation. As electrical professionals, it is our responsibility to ensure that all electrical systems are installed and maintained in a safe manner. By following the requirements of the NEC, we can help to prevent accidents and protect the lives of those who work and live in hazardous locations. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. It is important to stay informed about the latest changes to the NEC and to consult with qualified electrical professionals to ensure that your electrical systems comply with all applicable requirements. The NEC is a complex and comprehensive document. It is not intended to be a substitute for education, training, or experience. It is important to seek out qualified electrical professionals who have the knowledge and skills necessary to properly design, install, and maintain electrical systems in hazardous locations. The NEC is a valuable tool that can help to prevent accidents and protect lives. By following the requirements of the NEC, we can create a safer and more reliable electrical system for everyone. There are several key aspects to consider when dealing with electrical installations in hazardous locations according to NEC Article 500. Firstly, understanding the classification of the location is crucial. This involves determining whether the location is Class I Roman II or Roman III, and then further classifying it as Division I or Division II, based on the likelihood of the presence of hazardous materials. Secondly, selecting the appropriate equipment is essential. Equipment used in hazardous locations must be specifically designed and certified for the class, division, and group of the location. This equipment is designed to prevent ignition of the hazardous atmosphere. Thirdly, proper installation practices are paramount. Wiring methods, sealing requirements, and grounding and bonding procedures must be strictly followed to prevent the creation of potential ignition sources. Fourthly, regular inspections and maintenance are necessary to ensure that the electrical system continues to operate safely. This includes visual inspections, testing, and replacement of any damaged or deteriorated components. Fifthly, personnel training is critical. Workers who install, maintain, or operate electrical equipment in hazardous locations must be properly trained in the specific hazards and safety requirements of the location. The NEC provides detailed guidance on all of these aspects. It is important to consult the NEC and other relevant standards to ensure compliance and to maintain a safe working environment in hazardous locations. In addition to the NEC, other organizations such as the National Fire Protection Association, or NFPA, and the International Electrotechnical Commission, or IEC, also provide standards and guidance on electrical safety in hazardous locations. It is important to be aware of these other resources and to follow the most stringent requirements that apply to your specific situation. The ultimate goal is to prevent fires and explosions and to protect people and property from the dangers of hazardous locations. Always prioritize safety and consult with qualified professionals when working with electrical equipment in these environments. The National Electrical Code, Article 500, provides specific guidelines for electrical installations in hazardous locations to minimize the risk of ignition. This involves classifying locations based on the type of hazardous material present, which is either gases or vapors, dusts or fibers, and the likelihood of its presence under normal or abnormal conditions. This classification determines the type of equipment permitted. For instance, explosion-proof enclosures are used where flammable gases or vapors are present to contain any internal explosion, preventing it from igniting the surrounding atmosphere. Another method is intrinsic safety, which limits the energy in electrical circuits to levels that cannot cause ignition. Purging and pressurization systems are employed to maintain a clean, non-hazardous atmosphere within enclosures. Wiring methods are also crucial, requiring sealed conduits and specialized fittings to prevent the migration of hazardous substances. Regular inspections and maintenance are necessary to ensure the continued integrity and safety of the electrical system. Compliance with Article 500 is essential in preventing fires and explosions in hazardous locations, protecting personnel and property. Understanding the specific requirements for each classification and ensuring proper installation and maintenance are key to a safe electrical installation.